Pythagorean's theorem and trigonometric ratios. Pythagorean theorem was developed and created by Euclid over 4,000 years ago. Hence, when we look at geometry, it's called Euclidean geometry. This is two-dimensional geometry. And basically what it states is that the three sides of a right triangle, if we square two of the sides that are each touching the right angle, it'll equal the square of the third side. Take the square root, you have the length. The original shape he looked at was a right triangle with legs, that's the straight sides that are next to the right angle, 3 and 4. And he said 3 is A, 4 is B, and developed A squared plus B squared is C squared. Well, 3 squared is 9, 4 squared is 16. And 16 times 9 is 25. And what he found out, basically, was when he took the square root of that 25 right here, it ended up being 5. And that was the exact answer, what it was when he measured it manually. And it worked for actually for every right triangle, excuse me. I want to go through some examples here. If I have a right triangle, and how do I know it's a right triangle? It's got this right angle right here. It'll always have it if it is a right triangle. And each of the parts touching the right angle, called the legs. The longest part, opposite right angle, is called the hypotenuse, which is H. And let's just look at this. We've got legs here, 12 inches, 9 inches. A squared plus B squared is C squared. So I'm going to put 9 squared plus 12 squared. 9 plus 12 is squared. Each one of them is 81 plus 144 will equal C squared. 81 plus 144 is 225, which is C squared. The square root of 225 equals square root of C squared. We're just doing basic algebra here. Whatever we do to one side, do the other. And the square root of 225 is 15. The square root of C squared is C. So my X equals, right here, 15 inches. And again, the longest side opposite the right angle is called the hypotenuse. So another one here. And we have to remember how we're setting this up. I've got a leg here, 12 inches. I don't know the leg here. And my hypotenuse is 13 inches. It's opposite the right triangle. So I got to set this up. My A squared is B squared is C squared. So one of my sides is 12. My hypotenuse is 13. So it's going to be 12 squared plus my unknown, x squared, equals 13 squared. 12 squared is 144. C squared is 169. And remember, when we do algebra, we have to balance. So if we subtract something from one side, we have to subtract that same amount from the other. 144 minus 144 is 0. That leaves the x squared here. If I do 144 on the left side, I have to do it on the right side. 169 minus 144 is 25. So my x squared equals 25. Square root of x squared is x. Square root of 25 is 5. So my x here is 5 inches. Now we're going to ask here, is it a right triangle? I've got all three sides here. And remember what I said, the longest side, the hypotenuse, is always opposite. So this is the longest side. One side is 6 feet, one side is 8 feet, one side is 9 feet. We're going to see if it's a right triangle. That should be the C side. The C squared. I don't know why I put 12 there. That should be 9 squared. Well, my A squared is 6. It's 36 squared. My B squared would be 8 squared, which is 64. And 34 plus 36 plus 64 equals 100. And even with my wrong answer, that equals 81. 9 squared is 81. And 100 does not equal 81. So this is not a right triangle. Let's check this one. I'm going to do what I did before. I got size my A, B, and C. Well, ultimately, my longest side is 14.87. That's going to be my C squared, because that's the longest side. And we'll see if it's opposite of this potentially right angle here. Here's a leg, 5, and here's a leg, 14. So 5 squared plus 14 squared is 14.87 squared. 5 squared is 25. 14 squared is 196. 25 plus 196 equals 221. 14.87 squared is 221. So this is a right angle. Now, I want to go over some proportions here because this is going to be important in understanding trigonometric ratios. First, remember, similar triangle is if they have the same angles, then they are similar. Not the same lengths, but they have the same angle. But here's what's interesting. If I have similar triangles, each with the same angles, the proportions are going to be the same of those lengths here. For example, on my triangle X here, I've got 60 degrees here, which I also have here. I have 30 degrees here, which I also have here. And here's my right angle, which is 90 degrees. And I've got 9 degrees right here. So these are similar. And when I actually measure these out, if my legs are A and B, this is 2, this is 3.46, and this is 4. Look what happens when I double this. 2 times 2 is 4. Got the same angle here. 4 times 2 is 8. 3.46 times 2 is 6.92. So basically, what I'm proving here is proportionality. And when I look at this here, my ratios of A to C, A is 2, B is 3.46, C is 4. Here's my triangle X, it's 2 over 4, which is 0.5. And the other side here, my triangle Y, 4 to 8, still 0.5. Now my B to C, my B leg to my hypotenuse, 3.46 to 4, which is 0.865. 6.92 to 8 in triangle Y is also 8.65. And then the ratios of A to B, one leg to the other, 2 to 3.46 is 0.578. 4 to 6.92 is also 5.78. This is important understanding the proportionality with trigonometric ratios we'll be talking about for the next week or so, actually. Now, the best way to remember this is the term SOHCAHTOA. SOHCAHTOA. And we have certain terminology here. We want to look at the sine. The sine is the opposite over the hypotenuse. Now, what I'm looking at here is I'm looking at this angle right here, right now. The sine is the opposite of this angle. So it's the length. So it's 4 for the opposite side and 5 for the hypotenuse, which I put here 4 here out of 5. And that equals 0.8. That is my sine of this angle right here. The cosine is the adjacent hypotenuse. Let me erase this here. And when we're talking about the adjacent, let's say I'm talking at the same angle. Here's the adjacent angle. Here's the angle. Adjacent means it's touching it. It's this side over the hypotenuse. So it'd be 3 over 5, which is 0.6. And the so coming from sine over hypotenuse, first letter in each one, SOH. So then the ka comes from cosine equals adjacent over hypotenuse, the ka. And then tangent, koa, which is tangent, which is opposite over adjacent. And then opposite in this case is the opposite of this angle, which is 4 over the adjacent of this angle, 3, which is 1.33, toa. Just remember the phrase SOHCAHTOA. You can remember what the sine, cosine, tangent equal. Let's find some sines here. Now, it's not going to be in either angle, but we're going to look at, we got to define which angle it is. And I look at this here, sine of C. So here's C. And what I'm going to do here is I am going to look at the opposite here. The opposite is 21. The hypotenuse is 29. So my sine of this, C, is 20 over 29, which is 0.724. Now, how can I determine the angle here? What I can do is actually bring up my calculator here, and I'm going to put in 21 divided by 29 equals, there's my 0.724. And I've got the trigonometric function right here. And I'm going to hit, I have to be careful here. I got to hit, that's already signed. I got to do the sign of -1. And I get 46.39. Let's try another one here. Sine of A. Remember, sine is opposite. So when I look at this, I'm going to look at, here's my A. What's the opposite of this angle A? It's 40. And then hypotenuse. Sine equals opposite over hypotenuse. So 40 over 50 is 0.8. Now let's find what that angle is. Do as I did before. I'm going to get my calculator out here. And what I'm looking at here is, and it's 0.8, but let's go through it technically. 40 divided by 50 equals 0.8. And I've got second here already hit. Right there, sine -1, and it's 53.13 degrees. Let's do a cosine here. I've got, find the cosine of C. Here at C, cosine, remember, COA, which is adjacent over hypotenuse. So that is adjacent side to C is 36. The hypotenuse is 39. When I divide that, I get 0.923, but we'll get my calculator out. And 36 divided by 39 equals, oh, I messed up here. Try this again. 36 divided by 39 equals 0.923. I'm going to go to the second here. Sine or cosine -1. I get 22.62 here. And I put 24.63 down here, but for all practical terms, it is the same angle, 22.6 degrees. Let's look at the cosine for this triangle. And it's a right triangle, so we know we can use trigonometric functions for this. Get my calculator out ahead of time this time. And it is the cosine of C. And what am I looking at here? I am looking at here C, the cosine of that C is 8. That's 8 over the hypotenuse 17, which is 0.471. So I'm going to do 8 divided by 17 equals 0.47058, which is 0.4471. I'm going to do trigonometry. Second hits cosine -1, and I get 61.927. This 1.9 here was what I wrote. Similar for all practical purposes. Do a couple tangents here. Remember, tangent is opposite over adjacent. So here is my angle A. My opposite is 12. My adjacent is 35. So when I bring up my calculator, let's clear my previous problem here. 12 divided by 35 equals 0.3428, which I moved up to 0.343. Hit my trigonometry function, hit second so I can do the tangent inverse. I get 18.9246, which rounded to 18.93. So that angle is 18.93, as I am showing right here. Let's do one more. I've got looking for tangent of Z. Remember, again, that is opposite over hypotenuse. No, opposite over adjacent. So, and what's interesting is I've written this wrong here. I put 36 over 27. So that actually should be 27 over 36, which is, I know this, 9 goes to 27 3 times, 9 goes to 36 4 times, that equals 0.75. So what I'm going to do, I'll get my calculator back out, and I'm going to find a tangent, inverse tangent of 0.75. So 0.75 tangent second inverse is 36.87. So that, because I did my original calculation wrong here. So this should actually be 0.75, and that should be 36.87. But the interesting here I want to point out, we'll see in the future. Remember, all triangles got to be equal to 180 degrees. Well, here's 90 right here. That means there's another 90 between the two. And what you're going to see is the tangent of one is the the sine of one is the cosine of the other. I got 36.87 here. And notice 36.87 plus 53.13 is equal to 90. So this, I did it reverse order. That's why originally was wrong, because I had it set up in the wrong direction. But it still adds 180 degrees, and I actually could figure it out the other way.